Okay, do you want us to get going now, Camilla?
Yes, please do.
Yep, okay. Great. Well, thank you everyone for joining the second annual Cochrane Bias Methods Group meeting. I first want to acknowledge the traditional owners and custodians of the land from which I'm speaking, which is the Wurundjeri people of the Kulin Nations, and I pay my respects to elders past, present and emerging. In this session, just letting everyone know, we are recording this session and we will be uploading it to the Cochrane Bias Methods website. And we have a series of presentations across the hour. If you have any questions, if you can please put them in the chat, and we'll try to get to them at the end of each section of the meeting. First off, what we're going to do is give a bit of an update from each of the co-conveners of the Bias Methods group. And I'll start off with Asbjørn.
Yes, I'll just share my screen. Can you see my screen?
Yes.
Great. Just a short brief overview of the activities of the group last year on behalf of the four co-conveners, Isabelle Boutron, Julian Higgins, Matt Page, and myself, and Camilla Hansen-Leisgaard, the BMJ Research Coordinator. We have roughly 350 members of the BMJ, a fairly large Twitter following of 2,300 approximately, and the BMJ website activity has been increasing slowly and steadily over the last couple of years, with roughly 65,000 visitors during the last year. So, focusing on activities, splitting up between meetings and communication and main activities, we've had 5 teleconferences with co-conveners and sent out 1 newsletter. Usually we send out 2, but the dates don't always correspond to that. So next year there'll probably be 3. Our main activities, though, has been focusing on ROB2 training and development, and the development and refining of other tools that we'll share with you in a moment, and auxiliary projects. So the new version of ROB2 came out in 2019, but last year there's been new versions of it focusing on cluster randomized trials and crossover trials available at riskofbias.info. These are test versions, and everybody are welcome to have a look at them. However, the main impetus has been on the implementation and training of ROB2 and parallel group randomized trials. There's been a number of webinars at the web address you can see. Matt Page, for example, held a webinar on domain 5 bias and selection of the reported result. Also, we contributed to the method support unit's web clinics. Other tools that the group's been working on has mainly been RobMe, and Matt will give a short brief overview of the status of that in a moment. Tacit, and I'll give a short overview also, and RobInS-E. RobMe is now in a preliminary version available in riskofbias.info. Everybody's welcome to have a look at it and provide feedback. RobInS-E, Risk of Bias in Non-Randomized Studies of Exposure, is forthcoming. Other main activities have been contributing to the COVID network meta-analysis initiative led by Isabelle Boutron, where training material has been provided and quality control. And also we contributed to reporting guidelines. The Spirit Consort revision is forthcoming, and PRISMA 2020 was published earlier this year. So plan for activities the next year basically is to continue the training and implementation efforts relating to Risk of Bias 2, and also to push forward with the tools to assess risk of missing evidence, ROB-ME, and addressing conflicts of interest in tacit. Thank you very much. Any questions, feedback, comments?
I might say questions for the end of this overall introductory session from the conveners, if that's all right with you. So stop sharing has been.
Yeah, I'm just trying to find it here. So there.
Excellent. So I'll just give a very quick overview of where we're up to with ROB-ME. So ROB-ME tool stands for Risk of Bias Due to Missing Evidence. And this is a new approach we've been developing over the last couple of years for assessment of non-reporting biases in meta-analyses. Essentially what we're trying to get at with this tool is to enable authors to look at a synthesized result, such as a meta-analysis result, and make a judgment about whether that meta-analysis result is at either low risk of bias, whether there's some concerns about it, or at high risk of bias due to either unpublished studies or selectively reported results of studies. So this essentially integrates the assessment of these two types of non-reporting biases. And it's primarily been designed to assess risk of bias in pairwise meta-analyses of the effects of interventions. But later on in the session, we'll hear from Virginia, who's extended this tool to network meta-analyses. And essentially, ROB-ME has been developed based on a review of existing tools and expert consensus, as well as some piloting. So we released a preliminary version of the tool in October last year, and that's available now for everyone to have a look at if you're interested at the riskofbias.info website. We include a template of the tool and preliminary guidance for completing the tool. And throughout the year, we've received feedback from 11 author teams, and I didn't actually count the number of attendees of 4 webinars that I've delivered over the year. And from the feedback that we've received from these individuals, there's definitely been a clear recognition from people of the value of such a tool for integrating these different types of non-reporting bias. This piloting exercise was very useful because it has identified some misunderstandings about how to complete certain steps. And there was definitely a clear request from, I think, everybody for the need for some work examples to help interpret how to apply the tool. So in terms of next steps, essentially I've incorporated that feedback, and what we will be doing is drafting a paper on ROB-ME with several work examples, hopefully to be distributed early next year, and also want to explore options for developing software such as Shiny apps for users to complete the tool. We also need to give a bit of time to think about how to better integrate ROB-ME assessments with other risk of bias tools, such as ROB2. But we have more detail on the tool is available at riskofbias.info. It's just a quick whirlwind overview. What I'll do is I'll stop sharing and I'll now ask Julian to give an update.
Thanks, Matt. Where's mine? Okay, so I mean, as John has given I guess the main news from the ROB2 camp, which is that we have released versions of ROB2 for crossover trials and cluster randomized trials on riskofbias.info. And they went up in a slightly revised form in March this year, which means if you look at this table, we now have, if you cross-tabulate whether a trial is individually randomized or cluster randomized, or whether it's got parallel groups or crossover from one intervention to another. We've got 3 tools out of the 4 possibilities. I've been thinking a little bit recently about integrating ideas for the crossover and cluster randomized versions to look at crossover cluster randomized trials or cluster randomized crossover trials. I'm not sure how best to describe them, because I was, for the first time, in fact, approached about assessing risk of bias in one of those, I think, last month. So I think it would be fairly straightforward to integrate that. And that's something, if anyone's particularly interested in bringing any expertise in that area into the fold, that would be great. Please get in touch. Just to note what are the real differences and how we've integrated them into the tools. In each case, we've added a domain. So we've got 5 established domains in the standard ROB2 tool, which are randomization, deviations from intended intervention, missing data, outcome assessment, and selection of the reported result. We've added 1 domain in each. For the cluster randomized tool, the extra issue is a key aspect of selection bias. It's in when participants are recruited into clusters. If people are aware of the cluster allocation, then there may be selective enrollment of participants into the trial. And that's an issue that we don't have in randomized trials, parallel group, individually randomized trials, but we do in cluster randomized trials. So we call the domain risk of bias arising from the timing of identification and recruitment of participants in a cluster randomized trial. Bit of a mouthful, but we want to be really explicit about what the problem is. And we've got a few modifications to other domains, such as introducing a question in relation to deviations from intervention arising from the trial context. If participants didn't even know they were in a trial, then that wouldn't happen. So we ask a very simple opening question in domain 2. Did participants know they were in a trial? And of course, we've got missing data issues, not only for individuals, but for clusters. So we've added questions just to be explicit about that. For the crossover trials tool, the extra domain we've called risk of bias arising from period and carryover effects. These are the 2 additional considerations in a crossover trial. We originally tried to squeeze them into the existing domains, but we thought it'd be much easier just to address them head on and do minor modifications to the other domains. And in fact, there is very little that's different about the other domains. A little bit of wording issues to recognize the crossover nature, and 1 extra question in the selective reporting domain in relation to whether we were looking for results based on both periods, but only 1 is reported on the basis of carryover. And we have a general strategy for addressing where only the first period is reported versus matched analyses based on 2 periods. I should say this is only really tailored to 2 ABBA crossover trials at this point, but it should be suitable for any pairwise comparison across 2 periods, even if the trial has got more interventions. As Bjorn also mentioned, that we've been working on Robbins E, and this slide just puts, this really is representing the entire family of tools that we're working on. And, you'll notice progress is slow. It's partly because we've got so many that we're working on and they each move forward a little bit. But in recent months, the primary driver through external forces has been Robbins E for follow-up studies. Essentially cohort studies looking at risk of bias in observational studies of exposures other than intervention. So less directly related to Cochrane, but we're really excited that we're very, very, very close to having the complete tool ready to put up on the website after several rounds of piloting, many heated discussions with environmental epidemiologists, particularly in North America, from quite different perspectives in the way they approach systematic reviews. But I think we've found a way through. The great news for Cochrane and people who are interested in intervention research is that pushing forward Robbins E has indirectly produced great leaps forward in our revision of Robbins I, which we've been working on for some time. And so as soon as Robbins E is up, the plan is to translate the latest improvements into Robbins I, and hopefully that'll be very nearly ready to put up shortly after Robbins E. So that's the excitement there. I think I'll stop in the interest of time. I could say a bit more about Robbins E, but I won't.
Thanks so much, Julie. And finally, Isabel.
Can you see my screen?
Yes.
Okay. Great. So thank you very much. So I'm going to give you an update of the COVID NMA initiative. This is an international initiative where our aim was to inform decision makers with high quality evidence synthesis during the COVID-19 pandemic. So this is an international initiative with several Cochrane entities involved, and particularly the BIOS Method Group. Our process relies on the three main pillars: a living mapping, where we identify all ongoing and registered randomized control trials to help funders decide which is the most relevant trials to plan; a living systematic review, and we'll come back into that; and a living monitoring feedback on the quality of ongoing trials. All our results are made available on the platform. And so we set up, for the living evidence synthesis, we set up a complex process where we identify all new trials with results, extract the data almost in real time as soon as we identify them, and assess the risk of bias. And once a week, we conduct analyses with production of forest plots and grading of the evidence. And our scope is really all trials evaluating any intervention for treating or preventing COVID-19. Currently, of the platform, the living mapping, we have more than 3,700 trials available through interactive data visualization. And for the living synthesis, we identify and extracted data from 581 studies. So on all the data on the platform, people can access details about study general characteristics, detailed risk of bias assessment for all outcomes of interest, and we are using ROB2 with a strong process with the BIOS Method Group, where a random sample of our data extractions are being assessed regularly by member of the BIOS Method Group with feedback to improve the assessment. We produce forest plots for all comparison and outcome of interest. So we currently have more than 12,000 forest plots available online for about 300 comparisons, but we produce more than 4,000 forest plots. And we have summary of finding tables and evidence profile for all comparisons. We also developed some tools that was developed by Anna Shimani with our PhD student that allow people to use the data we extracted and produce their own analysis, so they can select a comparison and outcomes and decide which meta-analytical model they want to use, whether they want to focus on specific populations, do subgroup analysis, or sensitivity analysis, excluding, for example, high risk of bias studies. And then they can obtain their forest plot that they can download. We initially decided to focus only on randomized control trials, but upon the request of the WHO, we recently decided to extend for a short time, actually, on observational studies to assess vaccine effectiveness on variant of concern. And for this, we set up a protocol and also decided to implement ROBINS-I, and with a strong collaboration with Julian and his team, who was doing ROBINS-I and allowed also some development for case control studies. The next steps is our plan to conduct network meta-analysis, and we set up a process to identify which were the relevant network and currently conducting the analysis. And we're also trying to request IPD to see whether we will be able to do some IPD and meta-analysis on network meta-analysis. And I'm going to stop here. Thank you very much.
Great. Thanks so much, Isabel. I just wanted to check if there were any questions that anyone had for any of the conveners based on those lightning talks just then.
Matt, we're missing one presentation, the tacit presentation. So if there is enough time, I'll give a lightning presentation on tacit as well, and then we can move on.
I think we're going to be fine to do that. So yeah, go for it.
Okay, perfect. Just a moment. So, is it on screen? Okay, great. Just a very short overview of the work we're doing on tool for addressing conflicts of interest in trials, TACIT, giving this on behalf of Andreas Lund, Isabelle Boutron, and Leslie Stewart, who are in the TACIT steering group. So conflicts of interest in randomized trials are quite common. Roughly 7 out of 10 drug trials are industry funded, and the same 7 out of 10 drug trials have authors with financial conflicts of interest. So financial conflicts of interest are very common. Non-financial conflicts of interest is a more thorny issue. The aim of TACIT, of the tool, is to facilitate a systematic and transparent assessment of notable concern for conflicts of interest in randomized clinical trials. So basically, it's focusing on how to handle conflicts, information on conflicts of interest or missing information on conflicts of interest in trials that are assessed in the framework of a systematic review. And the main aim here is to provide information that support analysis and review conclusions by sensitivity and subgroup analysis based on notable concern, and to provide information relevant to external validity, risk of bias assessed in Risk of Bias 2 tool, and risk of bias due to missing evidence, ROBME. So the status of the project now is that we have published 2 supportive projects, one systematic review on appraisal tools for medical research studies addressing conflicts of interest, finding that they do so fairly superficially, and another qualitative interview study published in the BMJ 2020 on influence and management of conflicts of interest in clinical trials. We have a pilot version ready. Want to tinker slightly on it, partly by quite considerable user testing and by having feedback from or results from a descriptive study of the financial conflicts of interest and the role of funders and academic researchers in trials included in Cochrane reviews. But the aim is to release the tool for wider feedback in a year, in autumn 2022. That was then the progress of the tool can be found on this homepage, TACIT 1. Thank you very much. I think I have that under 3 minutes, actually.
I'm very impressed, Asbjørn. Thanks so much. So what I think we'll do now is, if anyone has questions for any of us conveners, please put them in the chat and we'll be monitoring and can type our answers. But in the interest of time, I want to make sure our invited presenters get time to speak and have the opportunity for questions for them too. First up, I'd like to introduce Carol Lunny from the Knowledge Translation Program at Unity Health Toronto, who will be giving a presentation on methodological review of items for assessing bias in network meta-analysis. And so Carol has generously decided to attend, even though it's midnight at her location, and she'll be planning a recorded presentation, but then being available to answer questions live. So go for it, Carol.
Hello, my name is Carol Lenny with St. Michael's Hospital in Toronto and the Cochrane Hypertension Group at the University of British Columbia. I'll be talking today about our methodological review of items, which will provide the groundwork for the development of a new risk of bias tool for network meta-analysis. Please tweet us at Carol_Lenny and use the hashtag NMA. So we've received funding for this project through a 2021 CIHR project grant. We have no conflicts of interest to declare, and we wish to acknowledge the traditional, ancestral, and unceded territory of the Musqueam, Squamish, Tsolo, and Tsleil-Waututh nations, on which the research team operates in Vancouver, British Columbia. Our project team consists of the steering committee, our stakeholders, and the working group. The steering committee consists of myself, Julian Higgins, Ian White, Sophia Diaz, Andrea Trico, Brian Hutton, RG Veroniki, Jim Wright, and Penny Whiting. We're also working with students and an international group of stakeholders who will help us in our dissemination efforts. So for background, network meta-analyses can compare all treatments for a condition, whereas traditional meta-analysis can only compare two. Network meta-analyses provide evidence to clinicians faster than traditional meta-analyses due to the dearth of evidence from head-to-head comparative studies. For example, researchers recently showed that prostaglandins would have been identified 7 years earlier as the most effective drug class in lowering intraocular pressure for open-angle glaucoma if an NMA had been done at that time. NMAs help patients and their care providers choose the treatment that is the most important to them based on side effects and efficacies of all treatments. So why is it important to assess NMAs for biases? Without a risk of bias tool for network meta-analysis, knowledge users will not be able to tell whether a single NMA is at low risk of bias. Multiple NMAs are now being published on the same topic, and choosing from conflicting NMAs is impossible without a risk of bias assessment tool. In the study on the right, the authors found 28 NMAs on treatments for rheumatoid arthritis, all with different conflicting results. So if an NMA is at risk of bias and inappropriate methods are used, the validity of the findings can be compromised, which can impact on patient treatment and care. So in an empirical study by Zarin of 456 NMAs, 25% of them were of high methodological quality. 50% of these did not report if an assessment of consistency was conducted or whether they accounted for inconsistency if it was present. 13% of the NMAs reported heterogeneity assumptions for the random effects model. Similarly, Veroniki et al. Assessed reporting quality of 1,144 NMAs. They found that 28% did not report an assessment for consistency in their methods. NMAs did not report assessment of these assumptions in the methods and results, 31% and 40% respectively in the years 2016 to 2018. However, the good news is that both of these studies found that the quality of these NMAs improved over time. So we came to some conceptual decisions as a steering committee about the tool that we want to develop. These decisions were to use a domain-based structure with single questions, to develop our risk of bias tool as an extension to the robust tool, and as such, items that are equally applicable to all systematic reviews were excluded. For example, having two people data extract. Our risk of bias tool would be used in NMAs of all studies designs, not just RCTs. So our definition of a network meta-analysis is a synthesis of evidence on the relative effects of 3 or more interventions simultaneously. And the purpose of our ROB NMA tool is to adjust the degree in which the review methods lead to a risk of bias in the review results, the NMA results, and the author's conclusions. We aim to provide a tool to assess biases and limitations in the way in which the analysis was planned, analyzed, and presented. including the way in which the evidence was assembled. If these methods are inappropriate, the validity of the findings can be compromised. So here in this table, we show that several tools are designed with different purposes. Some for assessing reporting quality, some for assessing quality of conduct, but none of them are designed to assess the risk of bias in NMAs. For critically appraising the quality of reviews, all types of reviews, MSTAR2 checklist is the most commonly used tool and aims to evaluate the quality of conduct of reviews with pairwise or standard meta-analysis. ROBUS is a domain-based tool used to assess the risk of bias in systematic reviews with standard meta-analysis or with narrative review. It also assesses reviews' conclusions. To assess reporting quality of NMAs, users can use the PRISMA NMA statement or the NICE DSU checklist. And to assess the quality of conduct, users can use the 2014 iSport checklist. However, due to important methodological advances in the fields of NMA, the iSport checklist published in 2014 is outdated. So our objectives and methods. Our objectives were fivefold. First of all, to conduct a methodological review to identify items related to biases and network meta-analysis for potential inclusion in our tool, which is the focus of this presentation. Secondly, to conduct multi-round Delphi surveys with experts to select items to include in the tool. To conduct a survey to ask stakeholders about how they'll use the tool and what type of tool is used for them. To pilot test the draft tool for usability, efficiency, comprehension with different user groups. And finally, to develop and evaluate a knowledge translation and training plan for tool dissemination. My co-authors and I developed a research protocol, which is published at BMJ Open, seen here, and also as a preprint. So in our review, we included journal articles, guidance documents, and methods papers that describe items used to assess bias in NMAs. Excuse me. We searched Medline, the Cochrane Library, methods collections, and the Gray literature. We extracted data on the characteristics of NMA tools and methods, and items were initially extracted verbatim. We included items potentially relevant to bias, quality, or reporting in NMAs, and excluded items that were equally applicable to all systematic reviews, as they're covered in tools like ROBUS or MSTAR2. Items were extracted and analyzed initially by 2 authors, but then discussed by the steering committee through consensus. For our analysis, we grouped similar items and we split items so that each covers a single concept. We categorized items as related to general systematic review biases or NMA specific biases. And then we grouped items into domains by similar concept. So for our results. So after screening and data extraction, 59 studies were included, yielding 14 tools, checklists or standards, 12 guidance documents, 26 articles related to bias or methods, and 7 papers assessing the quality of NMAs. A final list of 22 items was included and were categorized by 3 items in defining network characteristics, 4 related to effect modifiers, 13 related to synthesis, and 2 related to authors' conclusions. The items were entered this past summer into a Delphi survey for experts to get their feedback on whether the items should be included or excluded. So in conclusion, rigorously developed methodological and reporting tools for NMAs published from 2012 to 2014 are now outdated and fail to incorporate methodological advances in NMA conduct. Our new tool will be current and aims to incorporate these new advances. Our methodological review of items yielded 22 items. A Delphi and stakeholder survey were conducted this past summer to further refine the items in the tool. And finally, our methodological review provides the groundwork for the development of the first tool to assess the risk of bias in a review with NMA, to provide a way to choose network meta-analysis evidence at the lowest risk of bias. So I thank you and I welcome any questions.
Thanks so much. So are there any questions for Carol? One question I have is, with the 22 items you've collated from this review, based on your observations of those, do you think that they are all the items that you need, or were there, did it stimulate some other items that could also be added and considered in the tool, or were they all pretty comprehensive, your review of the existing tools?
Well, that's a good question because, yeah, we believe that they are comprehensive. As a matter of fact, I think as a committee, we believe that if we do a really good job, we won't have any updates in the future. I mean, knock on wood, but hopefully, yes, we've covered everything.
And what sort of timeline are you looking for in terms of the rest of the tool development?
Yeah, I'm actually really happy with the progress that we've made. So as I mentioned, the Delphi and the stakeholder surveys are complete. We've done the analysis. We've written up some of these papers, so they're being circulated. So the next step is the piloting, Matt, which is what I was interested in because we're going to be heading that way. And I was wondering if you had, my question to you would be, do you have any lessons learned? Like what, tips and tricks could you, share?
I think what I learned from for the last 12 months is that sticking a tool onto riskofbias.info and hoping that people will come and pilot it is not an effective way of getting piloting feedback. So, so having to go and actually contact and tap people on the shoulder and then alert them to it and inviting them to provide feedback was pretty much the only way that managed to get that done. But there's some other things that would have been used in the past when we developed ROB2, where we held a piloting event and actually got people in a room for a couple of days to actually have some protected time working on the tool and trying out the tool and then giving feedback on that. And I think that would have been a good thing to do, I guess, pre-COVID times. But if that's something that is possible, I would also consider that.
Oh, great.
Yeah. Unless there are any other questions or comments, we might be able to come back to them. Yep, Asbjørn.
Yeah, thanks for a great talk. I was just interested in your perspective on the Delphi survey. Was it a valuable exercise in relation to the efforts of actually setting a Delphi up and contacting people? I mean, from a kind of a square-headed resource perspective, was it worth it, basically?
I hear a little bit of maybe dissent in the wind, but I could be I could be wrong about that.
No, it's just a question.
I think you're stirring the pot. I don't know. I think it'll always yield really interesting results. I mean, in our Delphi, we had some really great comments. I mean, we had, comments that, weren't that helpful, but I mean, the ones that were, some of the ones that were made, like even if it's only a few of them, were super interesting and helpful and just gave us a different perspective. So yeah, I think it's worth it.
Great, thanks so much. Well, in the interest of time, we'll now head on to our final presentation. So I'd like to introduce Virginia Gioia from the Institute of Social and Preventive Medicine at the University of Bern, who will be speaking to us about the ROB-MEN tool. So go for it, Virginia.
Thank you, Matt. Let me just share the screen. Can you see my screen?
Yes.
Okay. Thank you. Thanks for joining and thanks for the introduction. I will then just move straight to the rationale for developing this tool and also introduce an example. So here we have a network of antidepressant drugs for a specific outcome of interest. And let's say that we would like to go about and assess the reporting bias or bias due to missing evidence for a contrast, like, for example, the one indicated by the arrow here. In terms of direct comparison, obviously we know the various methods that are available for pairwise meta-analysis. However, in network meta-analysis, the estimates use both direct and indirect evidence. So actually, the direct comparison in this case contributes about 19%, and the rest comes from indirect evidence, comes from the rest of the network. So this aspect must also be taken into account even when assessing the reporting bias. But as of today, there wasn't really any framework, any rigorous framework to assess this type of bias in network meta-analysis. So what we wanted to do is having a proper methodology, a rigorous methodology to get to a risk of bias due to missing evidence with a level of low risk, some concern, or high risk for each of the estimates. And that's why we have developed the RobMen tool, which was informed by obviously the various approach that we all know and are described, for example, in the Cochrane handbook, as well as the RobMe tool, as Matt said earlier, and obviously it's pretty clear by the name as well. So the framework, the RobMen framework, is somehow can be described by this flow chart. So first of all, we consider all possible pairwise comparisons that can be made among the interventions in the network. And for each of the comparison, we do both a within study assessment of bias and an across study assessment of bias, which refer to what we normally call selective outcome reporting bias or publication bias, respectively. And then with these two elements, we classify each pairwise comparison as having no bias detected or suspected bias with the relevant direction of bias. Then we integrate these classifications into the evaluation of risk of bias for the network estimate, which is the main output of interest from our tool. Here we first need to decide if the contribution from a pairwise comparison can actually bias the network estimate. But we also need to consider those pairwise comparison without data and whether they can lead to bias. Finally, we also look at any presence or if there's any evidence of small study effects in network meta-analysis. And then we synthesize these three elements. We do so we have proposed an algorithm to do that. And we then classify each network estimate, classifying them as having low risk, some concern or high risk of bias, as I mentioned earlier. So to facilitate this process, we have developed an interactive app, which is available at this link, which semi-automates the steps, and the user can upload the data. I'm gonna show you with a demo that I've pre-recorded because depending on the size of the network, the analysis that are needed to run for some of the assessments can take a few moments. So obviously we didn't have time to do that today. So as I said, the user will upload the data and then select the parameters to run the analysis. This is showing what you will actually get as a output from the analysis, so a data summary as well as output from frequentist Bayesian network meta-analysis and network meta-regression. but I'm going to move straight to the actual output from the tool, which is, first of all, the pairwise comparison table, where, as you can see, all the possible pairwise comparison are grouped automatically by the app based on whether they have data for the outcome of interest, as you can see here in group A, or if they have data for only for other outcomes, like you can see the true here in group B, and then if they are totally unobserved, so they were not identified in the review, as you can see here in group C. What the tool also does automatically is reporting the total number of studies and sample sizes for both the total studies with the outcome of interest and in the total identified in the systematic review. And this is also, this part is also important for the first assessment, for the within study assessment of bias, which we obviously do for those extra studies that we found for which we don't have, which they did not report the outcome of interest. Like, for example, the demo just shown either this comparison in group B, as you can see here, or any comparison in group A, like number 6, for example, where there are 2 extra studies that did not report the outcome of interest. And here, each study needs to be assessed for selective reporting, selective outcome reporting. The user can also refer to the step 2 of the RobMe tool, and it needs to decide whether there is bias suspected or not, with relevant direction, by considering whether it's likely that the study did not report the outcome because of reason related to the p-value, the direction of the results, the magnitude, and so on. One thing is important here, obviously, to consider is the relative sample size in relation to the total sample size. As you can see, for example, in the 9th comparison, we have 5 extra studies not reporting the outcome of interest, but the additional sample size that these studies bring, it's not that much in addition to the total sample size that one already has. So that's why, for example, here, one would say that there is no bias detected, because the user can, in this case, it would think that it's not enough to affect the synthesized results. So, as I said, this assessment is done for only for comparison group A and group B, but for group C, we can do the across-study assessment of bias as well as for comparison. And here, this assessment is done primarily using qualitative considerations, as reported again in the Cochrane Handbook. Things like whether it was possible to get data from grey literature, or whether there is well-known publication bias in that field, and so on. And in addition to qualitative consideration, if there are comparisons with at least 10 studies, one can also consider quantitative techniques such as the funnel plots, the test per small study effect. And these are actually produced by the app, and they are available in the data analysis tab. If one wants to consider them, I think the demo is showing it now, yes. But as I said, this is only in addition to the qualitative considerations. And finally, once these 2 parts are done, they are combined to reach an overall bias judgment for each of the pairwise comparison, which can easily be done by pressing the use algorithm to calculate overall bias button, as shown by the demo there, which automatically give the level without the user having to do it manually, essentially. And what the demo is showing is that the user can also overrule the decision and pick another judgment. Once these judgments are ready, they are integrated into our main output of interest, which is the RobMen table here, where the estimates are already automatically split into mixed and indirect. And the first assessment here, as I mentioned earlier, is to consider the percentage contribution that comes from those pairwise comparisons that were judged with suspected bias. Which again, this is done automatically by the app using the contribution matrix, which is also available in the data analysis tab. And it's already, yes, split in the relevant direction of the bias. So what the user has to do, as it's being shown by the demo, is just to evaluate this contribution and decide whether there is substantial contribution from bias, whether it's favoring is going into a specific direction, or whether it's balanced, we call it like that, among the two directions. Like, for example, here, we decided that if there was at least a difference of 15 percentage points, then that would constitute a substantial contribution, as you can see from the first two estimates. But there are also cases where there is substantial contribution in general, but it's somehow split among between the two directions. And I think that the demo is showing you now. We have a few, yes, for example, the citalopram versus trazodone here is 18 and 15%. So that's why we had selected substantial contribution from bias balanced. The next assessment is the one that consider the unobserved, the bias from unobserved comparisons. This is important because if the reason why these studies are unobserved, the studies were not published, is due to the results found in the studies, then this can lead to bias. And because the previous assessment only, obviously the contribution only comes from the comparison with data, so from the direct comparison, we have to somehow integrate the assessment that we have done for the unobserved comparison, so for the comparison without data. But this is only, as you can see, is grayed out for the mixed estimates. So this assessment is only considered for the indirect estimates. And it's essentially, this column is just copying the, it's just taking the last column from the previous table, from the pairwise comparison table, and it's just copying it here. Finally, the last assessment for the Rodman table is to check whether there's any evidence of small study effect in the network meta-analysis. And what the app automatically does is to take the results from the network meta-analysis and network meta-regression. As you can see here, the results are already reported. And you can also have a look at the output of the network meta-regression in the data analysis tab. And here the user has to decide, has to evaluate this in the next column by comparing this to the unadjusted and adjusted estimates, by looking at the point estimate, as well as know how the credible intervals overlap or not. In this case, there was a good level of overlap and the point estimates were not that different. So actually all of the estimates were given a level of no evidence of small study effects. So finally, once again, we need to combine these elements, these three assessments, and it can easily be done once again by pressing the button at the top, which apply our proposed algorithm. And gives a level of low risk, some concern, or high risk of bias for each of the estimates. But if the user think that our algorithm rules are too strict, or maybe not strict enough, then they can overrule the decision. I think the demo now is also showing how what it would look like if someone overruled the decision. And yeah, here it is. So then when this is done, we have our main output of interest, and we can actually download this table. As you can see here, the previous table can also be downloaded, although I didn't show it in the demo. And this is particularly important, not just because obviously you can put it in a report, but it's also important because the RobMen tool, it's actually now integrated in the CINEMA framework, which is the framework to assess the confidence in network meta-analysis results. So if you are familiar with it, you might remember that this is what the reporting bias domain used to look like until recently, I think a couple of months ago, but this is no longer the case. So this was just a very simple assessment that one could do and just select undetected or suspected bias for each of the estimates. Well, actually, if you now go on the CINEMA software and the CINEMA web application, you will be prompted to include the table to the RobMen table from the RobMen app. So to conclude, as far as we know, this is the first tool to evaluate bias due to missing evidence in network meta-analysis. As I said, it's already been implemented in CINEMA, and the Shiny app is available for use, and the publication for the RobMen will be available soon as it's been accepted recently. But if you want to know more about the assessment, having more details, and also have look at more comprehensive examples, you can, a preliminary version of the publication is available in medRxiv as a preprint. So thank you for your attention, and I'm now very happy to take questions.
Thanks so much, Virginia. Very interesting presentation and great demo of the app. I see in the chat we have a question from Joe McKenzie. Can the methods you outline be adapted for component-based NMA?
Yeah, good question. We haven't. I'm not sure, to be honest. I think it should there should be an adaptation for that. I'm not sure. I'm not too much of an expert in component network meta-analysis, but I'm not sure if all assessment can be applied to that, I'll be honest.
Food for further research, maybe.
Yeah.
That. Do you have any other questions people have? Just something people might be interested in with the app that you've developed. Is there any limits on the number of comparisons and network geometry, or can anything be used essentially for the app?
No, I mean, the example I've shown you is quite a large network. So if it worked with that, I'm assuming that it's stable enough to work with any number of comparison. So yeah, there is no limit on, it can be applied to any geometry, any size. Obviously, to run some of the assessment as well as the analysis, the larger the network, the longer it needs, like any assessment basically. But there is no limitation about the number of studies, number of comparisons.
Great. Any other questions for Virginia? No? Well, thanks so much. And we've just hit the final minute of the meeting. So if anyone has any other questions they have for any of the speakers, do let us know, but otherwise feel free to contact any of us. And thank you so much, everyone, for attending. I'll give everyone a chance to say, does anyone have any questions? No? Okay, great. Well, thanks everyone so much for a great meeting. And as I say, happy for anyone to get in touch with any of us to hear more about our work and to contribute to all these tools we develop. We really appreciate any insight and feedback you might have. And we will see you next year, hopefully sometime in person next year would be great. Imagine that. So thanks a lot, everyone, and see you later.